So in this video, I'm going to talk about the basic concept of thermodynamics. So let's get started. What is thermodynamics? Thermodynamics is the science of energy transfer, which deals with the study of transfer of energy and its effects on the properties of a substance. Suppose I have a system. Suppose I have a cylinder in which the gas is filled and I constantly give heat energy to it. So what will happen? The temperature will rise, the pressure may rise. So how the properties changes if we give heat energy or energy to a substance. So it all's defined by the thermodynamics. And one more important thing, that it also describe the conversion of energy. Okay, if the energy so different energies are converted into different energy, so which is all possible by thermodynamics. Let's have a look for an example. Suppose I have a battery in which the chemical uh, process are occurring. So due to that chemical effect, we get electrical energy in a wire. So we are getting electrical energy by chemical energy. And if that electrical energy go through the wire, so the magnetic field produced around it. So we are getting a magnetic effect by electrical effect. And if we have two different poles, then we get attraction, then they attract to each other. And if we have same pole, then they repels. So we are getting mechanical energy by magnetic effect. So suppose the here I have a piston, okay, and which is doing a reciprocatory motion upward and downward. So due to its more sliding parts, what will happen? The friction will produce and energy, heat energy will go to the surrounding. So we are getting heat energy from mechanical energy. So here how the energy transfer into different energy, right? So this is our second example. Suppose I have a boiler which gives high pressure steam, superheated steam, uh, and if it passes through nozzle, so we get energy, we get um, kinetic energy. Okay, so what the nozzle does, it convert the heat energy into kinetic energy. And if that steam hit at the blade of turbine, so it will rotate and we will get the mechanical work, we will get the mechanical energy by kinetic energy or pressure energy. So turbine here also working as a energy converting device. So it convert the kinetic or pressure energy into mechanical energy. And if the shaft is coupled with the generator, so we get electrical energy by mechanical energy. So here so this is all possible by thermodynamics. Now there are some terms related to thermodynamics. Suppose this is so first we talk about state. So what is state? State is something like that which defines the condition of a system by its property. Okay, suppose we have a system and we check its property at a particular instant of time, so that will be the state. Okay, that will be the state for that system. So it should be at equilibrium, thermodynamic equilibrium. So only when the system is at thermodynamic equilibrium, then we can define the state of that system. Okay, so state is something like that which describe the condition of a system and the property of that system at particular instant of time. Now come on to the process. Suppose this is my P, pressure along y axis and volume along x-axis, and here I have a first state and this is my second state. So pressure generally shows the change in state, of a system as a result of flow of energy. Suppose there are lots of other state, intermediate state, which we get by uh, thermodynamic equilibrium. So all these state I get different small thermodynamic equilibrium state, and constantly when I join this, so I get a whole process from 1 to 2 state. Okay, so process is generally what shows the change in the state of a system on which we are doing thermodynamic study. Now the one more term is very important, the system. So system is a quantity of a matter. Suppose I have a pen in my hand, it's also a system. So it's a quantity of a substance or region in a space on which thermodynamic study is to be done, or you may say the um, focus is concentrated. So this is all thermodynamic system. So this is also further classified into three system: open system, closed system, isolated system. So what is open system? Open system is the system in which energy can transfer. Energy interaction may take place as well as mass interaction may take place across the boundary of a system. So energy will also transfer and mass will also transfer from open system. Okay, this is our open system. Now if I talk about closed system, so closed system is a system in which mass cannot transfer but energy interaction may take place across the boundary of a system. Okay, so that means the energy can go into the system and come out from the system, but mass can neither go into the system and nor come out from the system. So this is a closed system. And one more system is isolated system, the system in which neither mass can transfer to the system nor energy can transfer to the system. So neither mass can go into the system and nor energy can go into the system, and they both will not come out from the system. So this is all comes under the isolated system. Now if I talk about the example, so suppose I have a turbine. You can see here turbine. So we are getting mass as well as energy from it. Okay, so it is also converting the energy and we are getting mass. If steam goes from here inlet, then we are getting steam, the same amount of steam from outlet. So this is the open system. Nozzle is also an open system. Okay, the pressure cooker with whistle is also an open system. And closed system is a you can say the bulb, the engine cylinder with valve, without valve. Okay, and there are many more examples. If I talk about the isolated system, so the isolated system may be the universe. So universe is the very important example of isolated system because it is the energy remains constant. Okay, so from the conservation of energy, the changes in the universe by energy will remains constant. Energy is not coming in to the universe, neither it is going outside from the universe, sorry, nor it is going outside from the universe. So the best example is universe. And the isolated thermal flask is also the example of an isolated system. Now let's come to the short terms. There are some other terms. We know system, what is so boundary. So the boundary is a imaginary type of line which separates the system from its surrounding. It may be imaginary, it may be real, and it may be movable sometime. Okay, if suppose we have an engine cylinder, suppose we have an engine cylinder, so what will happen? Engine cylinder will move, so we will get a moving boundary. Okay, surrounding, everything external to the system is known as surrounding. Universe, system and surrounding together makes universe. So that's all.